Hello, this is question 3 on your mix exercise 7 from the applied textbook from year 12. So historical information finds that nationally 30% of cars fail a brake test. Give a reason to support the use of a binomial distribution as a suitable model for the number of cars failing a brake test. It says give a reason and it's 1 mark. Remember, the binomial distribution has to satisfy 4 things. So you could say any of them is a fixed number of trials. So fixed number of trials. You are checking a certain amount of cars. Fixed number of trials. They are independent from each other. So if a car from each other. If a car fails the test, doesn't mean that other car is going to fail the test. From each other. 2 outcomes. So the car fails the test or doesn't fail the test, and the probability is constant. So, and the probability is going to be this 0.3, yeah? So you can mention any of them, you don't need to mention all of them. Find the probability that of 5 cars taking the test, all of them pass the brake test. Be careful because here they say fail and here they say pass. So the probability of failing the test is 0.3, but then the probability of passing the test is going to be 0.7. So we can consider this a binomial. So it's going to be a binomial. We are checking 5 cars and the probability of pass the test is 0.7. No? So we need the probability of x being precisely 5. Probability of being 5 is going to be 0.16807. You can do this with the calculator. Is probability PD, n is 5, p is 0.7. Or another way of doing the question is just 0.7 to the power of 5, because is the first car failed the test, passed the test, which is 0.7, and the second and the third one, and so on. So I have 5 cars that pass the test, so I'm going to multiply the probabilities. Yeah, that's another way, and you get the same answer. Then C, it says a garage decides to conduct a survey of their cars. A randomly selected sample of 10 of these cars is tested. 2 of them fail the test. So we are back to fail the test, so the probability is 0.3. Test 5% significant level whether or not there is evidence to support the suggestion that the cars in this garage fail less. So my hypotheses are going to be that the probability is 0.3, like everywhere in the country, and H1, I'm going to check if the cars in this garage fail less. This is going to mean that this is a binomial. We are checking 10 cars, 0.3. The observed value is how many cars? 2 fail the test, yeah, so 2, and the significant level is 5%. So method 1, we are going to compare the probability of x being smaller or equal than the observed value, which is 2, with the significant level. So if you do this with the calculator, straight away binomial CD, we don't have to adjust anything, is 0.38. 0.38 is greater than the level of significance, which means we have to accept H0. There is not enough evidence, so write the line, there is not enough evidence to support the garage claim that the cars in their garage fail less. Yeah, garage claim. That's the first method. Second method, I'm going to find the critical region. Yeah, critical region is going to be given by a value, such as the probability of x being smaller than that value is smaller than the significant level. This binomial is in the formula booklet. Yeah, so is 10 0.3. If we go to n10, 0.3 is this column here, this one, yeah, 0.3, yeah. So the first value that is smaller than 0.05 is this one, which means x is 0. So my critical region is going to be x smaller or equal than 0, but cannot be smaller. So my critical region is just x equals 0. So if we want to say that the probability of failing is less in this garage, we will have to have 0 cars failing the test. And we have 2. 2 of them failed the test. So 2 is not in the critical region. In critical region, therefore we have to accept H0, which is the same conclusion that we found out with this method, and we should write this sentence the same way. Yeah, there is not enough evidence because we will need that no cars fail the test to say that this garage is better than everyone else. Yeah, that's all with this question.